Imagine a steel monster nearly 9 meters long, weighing 23 tons, armed with the most powerful cannon among all tanks of the First World War. A machine that could accelerate to 12 kilometers per hour when its competitors barely crawled at a speed of 6. Sounds like a weapon of victory, does it not? But this French tank, the Saint-Chamond, became a true nightmare for its own crews, burying hundreds of soldiers in the mud of European fields. And all because it was created not for war with the enemy, but for a war between French generals. The story of this machine begins not on the battlefield, but in the offices of the Ministry of War, where a conflict flared up, the consequences of which would prove more terrible than any battle. The end of December, 1915. Europe is drowning in the blood of trench warfare. Millions of soldiers sit in trenches, unable to move the front line even by a meter. Barbed wire, machine guns, and artillery have turned any attack into suicide. It is at this time that Artillery Colonel Estienne meets with engineer Eugène Brillier from the Schneider Company. They understand that an armored vehicle is needed that will break through the German defense. Their idea is supported by General Pétain, and the commander-in-chief of the French army, General Joffre, personally approves the project. Thus, the first French tank, the Schneider, is born. But not everyone rejoices at this success. General Muret, director of the Army's automotive service, flies into a rage. He is responsible for all motorized land vehicles in the French army. This is his domain, his power. And here some artilleryman and a civilian engineer have bypassed his department and received approval directly from Joffre. For a military official, this is not just an insult. It is a blow to reputation and influence. Muret cannot openly oppose Estienne's project because two influential people stand behind it. Therefore, the general chooses another path. He begins to hinder the development of the Schneider in every possible way, demanding endless modifications and additional tests. But this is not enough for him. Muret decides to create his own tank, which will eclipse the machine of Estienne and Brillier. For this task, the general summons Second Lieutenant Charles Fouché, an expert on tracked vehicles. Muret asks the question, is Fouché capable of designing a tracked vehicle that will cross a trench 1.5 meters wide? The general knows perfectly well that the Schneider is limited to 1 meter. Fouché answers confidently, I can do it in 4 weeks. It sounds impressive, but there is one problem. The trials of the Schneider are scheduled for February 21st, 1916, and today is already February 2nd. Fouché has not 4 weeks left, but only 19 days. The task seems impossible. Fouché receives at his disposal a tiny workshop with outdated equipment, 10 men, and 2 Baby Holt chassis. These are American-made tractors that the French purchased before the war for towing artillery. Starting the development of a tank from scratch is impossible. There is absolutely no time. The only chance is to modify the existing Holt chassis, lengthen the tracks, and create a longer undercarriage. Theoretically, this should improve cross-country ability and allow the machine to overcome wide trenches. But between theory and practice lies a chasm of 19 sleepless days and nights. Fouché's team works without stopping. People sleep 3 to 4 hours a day right in the workshop. Engineers draw blueprints by the light of kerosene lamps. Workers cut metal and weld seams to the point of complete exhaustion. Everyone understands that failure means disgrace, not only for them, but also for General Muret. And the general does not forgive failures. The pressure is monstrous, but the excitement is even stronger. They are creating not just a machine, they are creating a weapon in a war of ambitions, where the stakes are higher than on any front, and almost a miracle happens. On February 21st, exactly on the appointed day, a strange structure called Apparatus No. 1 Type A rolls out onto the test range. It is not yet a real tank, but rather a lengthened chassis covered with steel sheets to demonstrate mobility. But most importantly, it works. Fouché's machine easily crosses a trench 1 meter and 75 centimeters wide, exceeding Muret's requirements. The Schneider also passes the test. On February 25th, the Army places an order for 400 Schneider tanks. It would seem that the competition is over, but Mouret does not intend to give up. He orders Fouché to improve the design. The front part is redone so that barbed wire does not get stuck in the undercarriage. To increase cross-country ability, the nose of the machine is made sharp and long, like that of a ship. On March 17th, the third prototype already overcomes a trench 2.5 meters wide. This is a triumph. This is superiority over the Schneider in the main parameter. Mouret immediately turns to the company FAMH in Saint-Chamond, and in April 1916 receives an order for 400 Saint-Chamond tanks from the Artillery Secretariat. Here begins the real baseness. The company that is supposed to produce the Saint-Chamond is the same firm that the Schneider relied on for its production. When the factory begins to produce Mouret's tanks, the production of Estienne's machine comes to a halt. And most strikingly, all this happens without a single finished prototype of the Saint-Chamond, without full-scale trials, without informing Commander-in-Chief Joffre. Mouret simply uses his connections and administrative resources to push the order through. 400 tanks are ordered based on a lengthened chassis with metal sheets on top. No one knows what the final tank will be, what armament it will receive, or what its real combat effectiveness will be. This is no longer weapon development. This is revenge, clad in steel and blueprints. Now the designers face the task of turning the lengthened chassis into a full-fledged combat vehicle. And here another ambitious figure comes into play, Lieutenant Colonel Émile Rimailho, the technical director of the Saint-Chamond Company. This man is not just an engineer. He is one of the creators of the legendary French 75mm cannon of the model 1897, which became the symbol of French artillery. Rimailho is used to his decisions not being discussed, and his authority is unquestionable. It is he who will determine the look of the new tank, and it is his choice that will become fatal for the entire project. Before the war, Rimailho developed the 75mm TR Saint-Chamond cannon by order of the Mexican General Manuel Mondragon. The gun turned out to be powerful, with a barrel length of 28.5 calibers, capable of hurling a shell weighing almost 8 kilograms at a distance of up to 6,000 meters. For the lieutenant colonel, the question does not even arise. His cannon must stand on the new tank. Moreover, Rimailho insists on the central location of the gun in the nose part of the hull. This is a revolutionary decision for that time, as the British Mark tanks placed guns inside sponsons and the Schneider on the side in the right part of the hull. On paper, the idea looks brilliant. The central location of the gun makes it possible to fire directly in the tank's course. There is no need to turn the entire machine or rely on inconvenient side angles of fire. 75mm against 57 for the British and Germans is a huge advantage in firepower. The crew receives a weapon capable of piercing any enemy cover and destroying firing points from a safe distance. It sounds like a formula for victory, but the devil is in the details. A massive cannon requires a massive mount, and that, in turn, requires a huge hull. The designers are forced to create a tank 8 meters and 83 centimeters long, 2 meters and 67 centimeters wide, and 2 meters and 35 centimeters high. The weight of the machine reaches 23 tons, almost twice as much as the Schneider. At the same time, the length of the undercarriage remains the same because it was developed for a light chassis and not for such a monster. A monstrous disproportion is obtained. A huge, heavy hull balances on a relatively short track base. Imagine an adult trying to walk on stilts that are knee-length. This is approximately what the engineering solution of the Saint-Chamond looks like. But Rimailho does not retreat, and Mouret does not wish to admit the mistake. The project moves forward, gaining the inertia of a catastrophe. To at least somehow compensate for the weight, the engineers implement an advanced technical solution, an electric transmission. A 4-cylinder gasoline engine with a power of 90 horsepower spins an electric generator, which feeds 2 electric motors, each of which drives its own track. Such a system makes control smooth and significantly simplifies the work of the driver-mechanic. No need to mess with primitive gearboxes and clutches. It is enough to regulate the current supply to the motors. In addition, the electric transmission allows the tank to be easily turned by simply changing the speed of rotation of the tracks. On a flat road, the Saint-Chamond accelerates to 12 kilometers per hour, a fantastic speed for a tank of that time. The Schneider crawls at a speed of 8 kilometers per hour. The British Mark barely reaches 6. The secondary armament is also impressive. 4 8mm Hotchkiss machine guns of the model 1914 are placed in the front, rear, and sides. This gives circular fire with practically no dead zones, unlike the Schneider with its vulnerable sectors. The crew of 8 people works in a relatively spacious hull, where one can at least turn around and not jostle with elbows in cramped conditions as in other tanks. The armor consists of 11 millimeters at the front, 8.5 on the sides and rear, and 5.5 on the roof and bottom. This is comparable to the protection of other machines of that period, and theoretically should hold machine gun fire and shell fragments. On September 1st, 1916, the first finished Saint-Chamond rolls out of the workshop gates. Military engineers inspect the machine and wince. Tracks only 32 centimeters wide sink into the ground under the 23-ton mass. The clearance is catastrophically low, the legacy of the Holt tractors, from which this design grew. The center of gravity is shifted far forward due to the heavy cannon in the nose. Any engineer with experience understands that this machine will bury its nose at the slightest rise or obstacle, but production has already been launched. The order for 400 units has been processed. It is impossible to stop the process. Feverish attempts begin to fix the obvious flaws. The tracks are widened from 324 millimeters to 412, then to 500. Additional rollers are installed at the front and rear to improve trench crossing. The undercarriage is reinforced, which cracks under the unbearable load. The first 150 tanks receive a flat roof, but it turns into a trap for German grenades, which roll right under the feet of the infantry walking behind the tank. Engineers make a double-sloped roof so that grenades roll off to the sides. At the same time, the observation cupola is removed, sharply worsening visibility. General Estienne, who by this time had been appointed commander of the assault artillery, calls this decision absurd and demands the return of the cupola at least for the driver-mechanic. When the Germans begin to massively use armor-piercing bullets, it turns out that the armor of the Saint-Chamond is pierced through and through. Additional 8mm sheets are hastily welded on, bringing the protection of the front part to 19.5 millimeters. The weight grows, cross-country ability falls, and mechanical breakdowns become more frequent. The last 100 tanks receive the classic 75mm cannon of the model 1897 with a barrel length of 34.5 calibers and a firing range of 11,000 meters. True, in real combat, the tank still fires at a maximum of a few hundred meters, so the difference is purely theoretical. By March 1917, a year after placing the order, the Army receives only 48 finished tanks. Production moves at a snail's pace due to constant modifications and a shortage of components. The last Saint-Chamond will leave the factory only in March 1918. But the Army needs tanks right now. The Germans are not waiting. The command forms the first crews and prepares the machines for their baptism of fire. May 5, 1917. The Lafaux salient. 11 steel monsters line up before the German positions. The crews are tense. Commanders check communications. Loaders prepare shells. This is the first real test of the Saint-Chamond in battle. A chance to prove that months of work and millions of francs were not spent in vain. Artillery preparation ends, and the tanks begin to move. Within a few minutes, enthusiastic hopes turn into despair. The terrain in front of the German trenches has been turned by previous battles into a lunar landscape. Shell craters 2 to 3 meters deep, shattered trenches, fragments of barbed wire, piles of earth and clay. For the last few days, torrential rains have fallen, turning all this into a swamp. The Saint-Chamond begin the attack and immediately demonstrate all their design flaws. The first tank drives onto the edge of a crater. Its long nose pecks down and gets stuck dead in the sludge. The engine roars, the tracks spin, throwing up fountains of mud, but the machine does not move a centimeter. Narrow tracks do not hold the mass of the tank on the soaked ground, and the center of gravity shifted forward does its black deed. The second tank tries to bypass its stuck comrade and crawls onto a shattered trench. Its front part hangs over the void, but instead of rolling over the obstacle, the machine dives nose down, like a drowning man. The rear part rears up. The tracks spin in the air. The crew is in panic. The commander screams orders, but physics cannot be cheated. The 75mm cannon sticks out of the trench like a tombstone to the ambitions of General Mouret. The third tank turns to help, but its track flies off the rollers. The mechanic tries to fix the situation right under fire, but it is useless. The undercarriage does not withstand the loads. German machine gunners do not believe their luck. French tanks get stuck one after another, turning into stationary targets. Armor-piercing bullets begin to pierce the armor. Ricochets ring inside the hulls. One of the tanks receives a hit in the viewing slit. Shrapnel wounds the driver mechanic. Another catches fire from a hit in the fuel tank. The electric transmission, so convenient in peacetime, shows its vulnerability in battle. A spark from damaged wiring and the whole tank turns into a torch. The crew jumps out through the hatches, falling under machine gun fire. Only one Saint-Chamond out of 11 manages to break through the German defense line. Its commander found a relatively hard patch of ground and guided the machine between the craters. The tank moves further, but this is a Pyrrhic victory. Without support deep in enemy positions, it cannot hold the captured territory. The infantry cannot keep up with it. The other tanks helplessly stick out in the mud. By evening, the French retreat to their starting positions. The attack failed completely. On May 6th, the situation does not improve. Of the 11 tanks, only 2 are capable of continuing the battle. The rest are either hopelessly stuck, damaged, or mechanically broken. 3 machines are destroyed by German fire, but this is almost mercy compared to the fate of the others. Crews spend hours under shelling, trying to pull the tanks out of traps, risking their lives for machines that betrayed them from the first minutes of the battle. Mechanics work in mud up to their waists under shell explosions, fixing thrown tracks, patching holes, changing damaged rollers. The command is in shock. Reports from the front read like a verdict for the entire project. Tankers demand immediate changes. Widen the tracks even more, reinforce the undercarriage, add viewing slits, increase the armor. But the main problem, the monstrous disproportion between the length of the hull and the track base, the shifted center of gravity, cannot be fixed without a complete redesign of the structure. This would mean admitting that all 400 ordered tanks are a mistake, that General Mouret launched an unworkable machine into production, that revenge turned out to be more important than common sense. By November 1917, not a single group of Saint-Chamond is in combat readiness. The reason is simple and humiliating. There are no spare parts. Electric motors fail. Generators refuse to work. Tracks wear out in a matter of hours of operation. French industry cannot cope with the production of specific components for the electric transmission. Tanks stand in the depot, immobilized not by enemy fire, but by their own design features. Meanwhile, the company offers a radical solution. In June 1917, engineers present a deep modernization project. Raise the clearance to 56 centimeters, shorten and redo the front part of the hull, rework the layout, essentially create a new tank on the basis of the old chassis. But time has been lost. The light tank Renault FT is on the way. Compact, agile, cheap to produce. It can do what the Saint-Chamond cannot, go where the infantry goes. The proposal is rejected. Modernization will not take place. The French army forms 12 groups of Saint-Chamond, but not one of them covers itself with glory. Every exit to the battlefield turns into a lottery. How many tanks will get stuck? How many will break down? How many will even reach the front line? Crews hate their machines, but an order is an order. They climb into steel coffins and pray that another bump or trench does not betray them. Tankers envy their colleagues on the Renault FT, who, although sitting in cramped single-seat turrets, do not drown in mud at the first opportunity. 48 Saint-Chamond are converted into supply vehicles simply by removing the cannons from them. Tank transporters are obtained, capable of delivering ammunition and food to advanced units. But even in this role, they do not shine. The same cross-country ability, the same breakdowns, only without the ability to at least somehow snap back when meeting the enemy. The only advantage, there is more space inside for cargo, since there is no bulky cannon with ammunition. Trench warfare, for which the Saint-Chamond was created, becomes its gravedigger. Pitted terrain, narrow passages between craters, endless mud. All this is deadly for a machine with such a long hull and narrow tracks. The design intended to overcome wide trenches on a test range with solid ground turns out to be helpless in real frontline conditions. And yet, it was the superiority in trench crossing that was the main trump card with which Muret wanted to surpass the Schneider. The irony of fate is complete and merciless. The summer of 1918 changes everything. The German spring offensive runs out of steam, the Allies go on the counterattack, the front comes into motion. Positional warfare, which held armies in trenches for 4 years, suddenly ends. The defense line collapses, troops maneuver in open spaces. Battles are fought not for meters of pitted earth, but for kilometers of relatively intact territory. And here the Saint-Chamond gets its chance for rehabilitation. On flat, solid terrain, all the tank's flaws become less critical. There are no trenches in which to get stuck with the nose, no endless craters, no impassable mud. The tracks hold the machine on dry ground. The electric transmission allows for easy maneuvering. A speed of 12 kilometers per hour gives an advantage over infantry and horse-drawn transport. But most importantly, the 75mm direct-fire cannon turns the Saint-Chamond into a formidable assault weapon. The French command changes the tactics of application. Now Saint-Chamond do not climb ahead of the infantry through fortifications, but act as mobile support artillery. Tanks move behind the advancing troops, suppressing enemy firing points, breaking up counterattacks, destroying machine gun nests at a distance inaccessible to small arms. German soldiers, accustomed to repelling clumsy tank attacks, now face a completely different threat. The French machine stops at 500 meters, turns its hull toward the target, and begins to methodically crush positions with shells weighing 8 kilograms. 4 machine guns give circular fire, protecting the tank from attempts by infantry to get close with grenades. The armor holds rifle fire, and there are still few German anti-tank guns on this sector of the front. The crews finally feel that their machine is working as it should. No need to pull out a stuck tank under fire, no need to fix thrown tracks, no need to watch your steel monster helplessly sink in the mud. The Saint-Chamond moves, shoots, conquers. The role of the tank changes radically. From an unsuccessful breakthrough machine, it turns into an effective weapon of fire support. The breakthrough function is taken over by the light and agile Renault FT, capable of crawling anywhere thanks to compact dimensions and a rotating turret. And the Saint-Chamond follow them, destroying everything that tries to stop the offensive. Heavy tanks no longer storm fortifications. They crush resistance with firepower from a safe distance. August, September, beginning of October. Saint-Chamond participate in a series of successful operations. Loss statistics drop sharply. Machines return from combat missions intact. Mechanical breakdowns become rarer thanks to working on normal ground. Crews no longer consider their tanks coffins on tracks. Something resembling morale appears. Maybe, after all, these 23 tons of iron are worth something. Early October 1918, the Montfaucon area. The American 1st Division advances on German positions, and meets fierce resistance. The French command sends a group of Saint-Chamands to support the Allies. The tanks take up positions and open fire on German fortifications. 75mm shells burst in the trenches. Machine gun nests fly into splinters. German infantry rolls back. The Americans go on the attack under the cover of French steel and take positions with minimal losses. This is the last battle of the Saint-Chamond in the First World War. On November 11th, the armistice is signed. Guns fall silent. Troops cease fire. 4 years of bloody slaughter end. Europe lies in ruins. Millions are dead. Empires have collapsed. The map of the continent is redrawn. And French tankers climb out of their machines and try to believe that this is really the end. For the Saint-Chamond, the war ended the moment it finally found its place on the battlefield. A few months of relatively successful use cannot redeem a year and a half of failures and disappointments. The appearance of the Renault FT made heavy tanks unnecessary. A light machine, cheaper, simpler to produce, lighter to control, and capable of performing most tasks. Why does the Army need the cumbersome Saint-Chamond with its capricious electric transmission when there is the reliable and agile Renault? The decision is made quickly and ruthlessly. All surviving Saint-Chamond are decommissioned immediately after the armistice. They are not mothballed, not sent to warehouses, not attempted to be sold to other countries. 400 tanks, created from the ambitions of General Mouret, are sent to the scrap heap. Torches destroy the machines one by one. Steel is melted down. Electric motors go for spare parts. Cannons return to artillery warehouses. By the beginning of the 20s, practically nothing remains of the formidable armada. Only one specimen survives, which the French preserve as a museum piece. It is sent to the Tank Museum in Saumur, where it is installed next to the Schneider, the eternal competitor and the cause of this entire story. Two tanks stand side by side, mute witnesses of a war of ambitions that cost the lives of hundreds of French soldiers. General Mouret got what he wanted. 400 tanks with his name went into production, eclipsing the Schneider in the number of orders. His ambitions were satisfied, reputation restored in the eyes of the military bureaucracy. But the price of this victory is measured in hundreds of ruined lives of French tankers, millions of francs spent in vain, and the failure of dozens of combat operations. Revenge turned out to be a cold dish that the general served not to the enemies of France, but to his own army. Colonel Estienne, on the contrary, became one of the fathers of the French tank forces. His compact concept formed the basis of the Renault FT, a machine that defined the development of tank building for decades to come. It was his vision of maneuverable, reliable tanks that turned out to be correct, and not Mouret's gigantomania with his steel monsters on short tracks. The story of the Saint-Chamond became a warning for all armies of the world. Military equipment cannot be born out of interdepartmental intrigues and personal grievances. A tank created to spite a competitor is doomed to failure regardless of the power of the cannon and the thickness of the armor. If you like this story about how generals' ambitions ruined hundreds of soldiers, write in the comments what military equipment to tell about next time, and be sure to subscribe to the channel to learn more incredible stories from military history.